Hello students, grade secondary 1 chemistry. Now we are still in thermochemistry unit. Today we are going to study a new concept called heat content. What's the heat content? Any substance stores energy. Why? Because each substance consists of atoms, and inside the atom there are moving electrons around the nucleus, so they have kinetic energy. Also, electrons have potential energy as a result of its presence close to the nucleus or around the nucleus. Also, bonds formed inside any substance have energy called bond energies. The sum of all these types of energy is called heat content and denoted by the letter capital H. So the definition of heat content of any substance is the sum of the stored energies in 1 mole of the substance. For example, here water reacted with sodium to form sodium hydroxide, hydrogen, and heat. Any substance, water stores energy, sodium stores energy, sodium hydroxide, and so on. Every substance here stores a certain energy called heat content. So any substance stores what is known as heat content of the substance. We can also define a new concept called heat content change, denoted by delta H. The heat content change denoted by delta H is the difference between the sum of the heat contents of the products and the sum of the heat contents of the reacting substances. Delta H, the heat content change, is equal to the sum, the sigma H products means the sum of the heat contents of the products minus the sum of the heat contents of the reactants. If you subtract the sum of the heat contents of the products and the sum of the heat contents of the reactants, you get a number. This number is called the heat content change, denoted by delta H. Standard heat content denoted by delta H naught. This is called naught. The heat content change under standard condition. It's the same as the heat content change, but are under conditions, special conditions called standard conditions. What are these standard conditions? Standard conditions is the pressure 1 atmosphere, 1 atm means 1 atmosphere. The temperature is 25 Celsius, which is called also the room temperature. And if there is a solution, the concentration of this solution must be 1 molar. These 3 conditions are called all standard conditions. The heat content of any element is considered equal to 0. 0 what is the unit of the heat content? Kilojoule per mole, because as we said before, that the heat content of any substance is the heat stored per mole of the substance. So the unit is joule per mole, or kilojoule per mole, or calorie per mole, and so on. The heat content of any element is considered to be 0 because the element is virgin, it doesn't react. So it is considered that the heat content of any element like nitrogen, oxygen, sodium, iron, and so on, any element alone has a heat content equal to 0 kilojoule per mole. But the heat content of any compound is not equal to 0. Okay, the heat of formation of any element also is equal to 0 because the element is not formed from elements, it is a simple substance. So the heat of formation of any element is also equal to 0. So the heat content of any element equal to 0, the heat content of any element is also equal to 0 kilojoule per mole. For example, in the following equation, nickel and carbon monoxide and phosphorus trifluoride react with each others to form this complex compound. The heat of formation or the heat content change equal to 0 for which of these? The heat content is equal to 0 for only elements. What is the element here? This is nickel, this is carbon monoxide, this is phosphorus trifluoride, this is nickel and carbon monoxide. Of course, for element only, so the answer is A, because nickel is an element, but all these are compounds. In the following equation, carbon plus oxygen gives carbon monoxide. Delta H naught F, which is called the standard heat of formation, doesn't equal 0 only for compound, but equal 0 for elements. This is element, so its heat of formation or its heat content equals 0. Also element. This is a compound, so the answer is this. Which of the following whose standard heat of formation doesn't equal to 0, also is not equal to 0 for compound, but A, B and C are all elements, so these elements have heat content or heat of formation equal to 0, but for compounds the heat content or the heat of formation is not equal to 0. What is the difference between these two equations? The first one is only a chemical reaction, a chemical equation, but this one is called thermal chemical equation or simply thermal equation. Why? Because this equation contains heat. This is heat, unit of heat, 710 kilojoule. It's not depends on the number, but only kilojoule. So this equation tells us that this reaction gives out energy, but the first one doesn't contain heat, so it's only chemical equation, but this one is called thermal chemical equation. Okay, thermal chemical equation. So a symbolic chemical equation that includes the heat change accompanying the reaction and is represented in the equation as one of the reactants or products. This is the definition of the thermal equation. So the answer is thermal equation, scientific term. These reactions can be classified into two types. Some reactions gives out heat, so the temperature increases. When you touch the container of the chemical reaction, you note that the temperature increases. Other chemical reactions, when they occur, the temperature becomes low, as is clear here. This reaction consumes energy, so this reaction is called endothermic. The first one, at which the temperature increases, is called exothermic reaction, while the other one, in which the temperature decreases, is called endothermic reaction. So we can classify chemical reactions into two types: exothermic reaction and endothermic reaction. The first one, exothermic reaction, is defined as the reaction that produces heat to the surrounding and its temperature increases, while the definition of the endothermic reaction, the reaction that absorbs heat from the surrounding and its temperature decreases. From the equation, the heat is on the right hand side, so this reaction gives out energy, so this is exothermic reaction. This equation tells us that heat is consumed, so heat is present on the left hand side of the equation with the reactants. So this means that this reaction consumes heat or absorbs heat, so this reaction is called endothermic reaction. This is an example for exothermic reaction. The heat is on the right hand side, while this one, at which the heat is on the left hand side. This is exothermic reaction, while this one is endothermic reaction. Here the heat content change for the exothermic reaction, delta H is equal to minus, negative value, while that one, which is an endothermic reaction, at which the delta H naught, which is called the heat content change, or the heat of the reaction, or the enthalpy change, equal to plus value. Here in the exothermic reaction, the heat transfers from the system to the surrounding, while this one, the heat transfers from the surrounding to the system. This is an image for exothermic reaction. Heat gets out from the reaction vessel. Okay, these arrows tells us that heat gives out. But this one, the arrows is inwards, which means that this reaction absorbs heat from the surrounding. This is the surrounding. Okay. This is a comparison between the exothermic and endothermic reaction. This is a paragraph for exothermic reaction. The heat content of the reactants is greater than the heat content of the products. So this reaction gives heat. This is high energy reactants, but products have lower energy. So the difference, which is called delta H, will be here negative, because when you subtract the heat content of the products from this one minus the heat content of the sum of the heat contents of the reactants, this gives negative value, because this is low minus this is great, gives negative value. So delta H here is negative. While here in the endothermic reaction, the reactants contain lower heat content, so these absorb energy, delta H, to become products that have high heat content. So by absorption of heat, the heat content increases. So when you subtract the sum of the heat contents of products minus the sum of the heat contents of the reactant, this gives positive value, because this is great minus low value gives positive. So delta H here in the endothermic reaction, delta H is positive value. These are examples for exothermic reaction: combustion of a candle, combustion of fuel, explosion. These reactions are exothermic reactions, while photosynthesis is an example, because plant absorbs light, which is also energy, absorbs energy, which is light here. Absorption of any form of light, of energy, this means that this reaction is endothermic, while giving out energy is exothermic reaction. These are examples for exothermic reactions, and these are examples for endothermic reactions. From the equation, we can know or determine the type of the reaction. This is heat on the right hand side, so this reaction is exothermic reaction. In this reaction, delta H is positive, so this means that this is an endothermic reaction. Here delta H is positive, it's also an endothermic reaction. Here the heat is on the left hand side, so this is an endothermic reaction. Here the heat is on the right hand side, so this reaction is exothermic, and so on. This paragraph is for an exothermic reaction. Why? Because the heat content, the sum of the heat contents of the reactants is greater than the sum of the heat contents of the product. So when you subtract the sum of the heat contents of the products minus the sum of the heat contents of the reactants gives a negative value. This is small number 75 minus the heat content here is 150. 75 minus 150 gives minus 75 kilojoule. This is the value of delta H, kilojoule per mole. Okay. This is an endothermic reaction. Here the heat content is low, but here the heat content is large. So this reaction is endothermic. It absorbs energy, so its energy increases from the low value to the high value. Now we arrive to the end of this lesson. Thank you for listening.